Yo, what's up guys? Patrick here, welcome back. And in this question, we're given this function e to the power of 4 times e to the power of the 5th root of x over 3, and we got to find the inverse of that function. So first thing I'm going to do is I'm going to take this function and I'm going to rewrite it over here. So we got e to the power of 4 and e to the power of 5th root of x over 3, like that. And then what we got to do, we got to interchange the x and y values. So we'd have the 5th root of y over 3 over here. And now what we got to do is we got to isolate for this y and get everything now in terms of x. So interchange it, and that's going to be the expression for the inverse. So how are we going to do that? Well, notice this e to the power 4 here. This is just a constant. So the first step you can do is you can divide both sides by e to the power 4. And then we just have this expression left on the right side. But what I'm going to do is I'm actually going to combine these two into one exponent, because notice that there are two exponents that are multiplying with the same base, meaning that we can take the exponents and we can add them. Now you don't necessarily have to do this step, but I just feel like having one expression on that right side is going to be a lot easier. And so now what we can do is we can ln both sides in order to isolate for this exponent, because remember, we're trying to isolate for this y, and this y is in an exponent right now, right? So just in general, as a review, whenever you got something like this in this format, where this a and this b, they could be variables, they could be numbers, they could be expressions, like in this case, and we want to isolate for this b, basically that b is equal to ln of a. So that's what we're doing over here. And so basically what we can do now is we can bring this exponent down. So we'd have 4 plus the 5th root of y over 3, and then we'd have ln of e. Now ln of e is just 1. So we can ignore that, and then we got ln of x here. Okay, so writing what we have over here so far, we got ln of x equals 4 plus the 5th root of y over 3, like that. And so now what we can do, bring the 4 over. So we'd have ln of x minus 4 equals, now the 5th root of y over 3, I'm going to rewrite that as y over 3 to the power of 1 over 5, right? The 5th root of something is the same thing as that to the power of 1 over 5. And we want to get rid of this exponent. Remember, we're trying to isolate for this y. So what we can do is we can take both sides to the reciprocal of that exponent. Now the reciprocal of 1 over 5 is 5. So we take this side to the power of 5, take this side to the power of 5, like that. Right? The reason why we take it to the power of the reciprocal, because now that original expression times the reciprocal, that's always going to give us 1. So you'd have y over 3 to the power 1, and over here we got ln of x minus 4 to the power of 5. And then this 1 here, we don't even have to write that. And then what we can do is just cross multiply. So 1 times y gives us y, and then 3 times this expression. We can't really distribute that 3 inside the bracket, so we would keep them separate like that. And so now notice we isolated for the y, and it's all in terms of x. So that there is the final answer to this question. This here is the inverse to that function right there.